There are a handful of different derivative tricks you can use to find the derivative of certain functions. For example, there's product rule, chain rule, quotient rule, power rule, and maybe you have a pretty good grasp on all those things. But what happens when you have a problem where you have to apply chain rule and product rule combined into one process? That's like a whole nother problem, right? Probably a bit more difficult just because there's a lot of different steps to keep track of. Well, in this video, I'm going to be showing you exactly how to go through a problem where you have to find the derivative of a function using the chain rule and product rule combined into one problem. And this is likely something that you're going to run into as you try to take the derivative of more complex functions, which may be on homework or on a test. So it's definitely something you want to make sure you're familiar with and feel pretty confident that you could do. If that sounds good to you, be sure to stick around to the end of the video, and if you do find it helpful along the way, please go ahead and hit that like button down below. It's a huge help to me and my channel, so I can keep making more videos like this. But anyway, let's go ahead and jump into the example and I'll show you what I'm talking about. We're going to find the derivative of y equals e to the x times sine of x. So like I said before, product rule, chain rule, both of these are on my Calculus 1 study guide. There's a link down in the description or the pinned comment below where you can learn more about that. It's free and it's available for instant download, so go grab yourself a copy. It's right down there. But anyway, let's go ahead and talk about how to do this problem. So just like I've been doing for the prior two examples, let's think about order of operations. If we plug in some x value here, what order are we going to do this? And I'm going to go through this a little bit quicker, but basically in this case we would have to deal with this power first, because this is where all of our x's are. So we would have to deal with that first of all. And then the final thing we would have to deal with, after figuring out what this whole power equals, is raising e to the power of that number, whatever it ends up being. So basically this exponent here, raising up to the power, is the final thing we have to deal with, e raised up to some power. So basically what that tells you is the final thing you're dealing with is e raised up to some power, or like evaluating e to the x, e raised up to some number. So that tells us, in this case, since that's the last thing that we would do if we were plugging in some x as an input into this function and figuring out what it's equal to, we're going to do our derivative in kind of the reverse order. So that's going to be the first thing we want to deal with. So this isn't really a product, e raised up to some power. In this case, since we have e raised up to some power, and that power itself has a couple of things going on, right? We have x times sine of x. We've got kind of x and sine of x being dealt with in there. It's a little bit more of a complicated function within our power. That tells us chain rule is going to be the first thing that we deal with here, because what we can do is we can think of an inner function and an outer function. So basically our inner function is going to be this power here. So inner function is the x times sine of x. And then the outer function is going to be whatever's left over if you change this inner function into just x. So our outer function is just e to the x. So based on that, we can go ahead and apply chain rule first. So chain rule says that the derivative of this function, once we figure out our inner and our outer, is just going to be the derivative of the outside function, leave the inside function alone, and then times the derivative of the inside function. So since we already have our inner and our outer, our inner function and outer function, we can start by just finding the derivative of the outer function. Well, in this case, since our outer function is e to the x, e to the x is a very interesting, unique function where its derivative is actually itself. The derivative of e to the x is just e to the x. So when we're taking the derivative of this, treating this as our inner function and this as our outer function, all we would have to do is take the derivative of the outer function, which is just e to the x, except we're going to leave our inner function alone, leave our inner function as our inner function. So that's going to be x times sine of x. And then multiply this whole thing by the derivative of our inner function. So the derivative of x sine of x. So now this is where the product rule is going to come into play. So this is going to be our y prime. Because now we still have to find the derivative of x times sine of x. Well, x times sine of x is going to require the product rule because we have the product of two things, x being one thing and sine of x being the other thing. So now we break this down into a product rule example. So this derivative of x sine of x, or x times sine of x, we have the product of these two things, so we can just say f is going to be x, g is going to be sine of x. And like I said, these formulas are on my Calculus 1 study guide. They're also covered in a lot more detail in my complete Calculus 1 package as well, if you want to check that out. The link is also down in the description. But once you find your f and your g, you then need to find f prime and g prime. So the derivative of f is just going to be 1, because the derivative of x is 1. The derivative of sine x, this formula is also on my free study guide, is cosine of x. So now product rule says we would multiply these across, so multiply f times g prime, f prime times g, and then add them together. So x times cosine x plus 1 times sine x, which is just sine of x. So now this right here is the derivative of x times sine of x. So basically now going back up to this step, we can replace this whole thing here with this whole thing here, because we just use the product rule to find that the derivative of these two things multiplied is all this. So basically what that tells us is our final derivative is going to be y prime equals e to the x sine of x times all this, x times cosine of x plus sine of x. And do be very careful. I do want to point out one thing here. You do need to make sure that this whole thing, everything within the box here, everything within these parentheses here, it needs to be all in parentheses, because this e to the x sine x would then, if you were to kind of, continue from here or actually have to use this somehow, this whole thing would need to distribute to both of the pieces within the parentheses here. So just something to be very careful of. Make sure when you're doing this chain rule that you multiply this whole thing times this whole thing. Basically the derivative of the outside piece, leave the inside alone, that's this whole thing right here, times the derivative of the inside. And those each need to be completely surrounded in parentheses. But that's going to be it. Basically, that'll be our final answer.
Well, I hope you found this video helpful and you're feeling a bit better about how to use chain rule and product rule combined into one process. If you think more tutorials like this would be helpful for you, go ahead and hit that subscribe button and that bell icon down below so you're notified when all my new videos come out, including many more like the one that you just watched. And if you want to keep learning about chain rule or product rule or any other type of derivative tricks, just go ahead and click on one of those videos over there and keep on learning. Thanks, and see you next time.